Every morning, billions of people begin their day with something they rarely think about. It sweetens coffee, powers bakeries, preserves food, and quietly fuels countless industries. Yet behind every tiny crystal lies an extraordinary journey, one that begins far from supermarkets and kitchen tables. Hidden inside endless green fields, gigantic machines, roaring factories, and precise scientific processes, sugar transforms from a living plant into one of the world's most essential ingredients. This is not just the story of sweetness. This is the story of engineering, agriculture, and human innovation working together on a massive scale. Visual description: aerial sunrise over endless sugarcane fields covered in morning mist. Slow cinematic shots of dew-covered leaves. Workers inspect crops while harvesting machines begin moving. Cut to giant factory chimneys releasing clean steam. Extreme macro of sparkling sugar crystals falling in slow motion. Sniff. Sugar appears simple, but producing it is anything but. Each crystal passes through harvesting, transportation, extraction, purification, evaporation, crystallization, drying, packaging, and worldwide distribution. Thousands of workers and millions of dollars in advanced machinery operate together in perfect synchronization. What looks effortless on a supermarket shelf is actually the result of remarkable precision and engineering. Visual description: fast montage of tractors, conveyor belts, crushers, evaporators, laboratory testing, packaging robots, shipping containers, and supermarket shelves. Long before modern factories existed, people discovered that certain plants contained a remarkable natural sweetness. Ancient civilizations chewed raw sugarcane for energy, while early societies learned to extract and refine its juice. Over centuries, simple techniques evolved into massive industrial systems capable of producing thousands of tons of sugar every day. The history of sugar mirrors the history of agriculture, trade, and technological progress itself. Visual description: ancient farmers harvesting cane by hand, historical illustrations transitioning into modern industrial plants through seamless visual effects. Most of the world's sugar comes from two remarkable crops: sugarcane, which thrives in tropical climates, and sugar beet, which grows in cooler regions. Both plants store energy from sunlight in the form of natural sugars. Although they look completely different, each eventually produces the same familiar white crystals found around the globe. Visual description: split-screen comparison of sugarcane fields and sugar beet farms. Healthy sugar begins with healthy crops. Farmers carefully monitor soil quality, rainfall, sunlight, irrigation, and plant nutrition throughout the growing season. Every decision affects sweetness, yield, and final product quality months later. Visual description: farmers checking crops, irrigation systems operating, drone views of organized plantations. When sugar content reaches its peak, harvest begins. Timing is critical. Delays can reduce sugar recovery, making speed and precision essential for both farmers and factories. Visual description: mechanical harvesters cutting cane, loading trailers, workers supervising. Freshly harvested sugarcane must reach the factory quickly. Every passing hour can reduce the quality of the juice inside the stalks. Logistics become just as important as farming itself. Visual description: truck convoys leaving plantations toward factories. Every truck entering the factory carries more than harvested plants. It carries the beginning of a complex manufacturing process. Before processing begins, every load is weighed, sampled, and inspected to ensure consistent quality. Visual description: factory entrance, weighbridge, unloading stations. Sugar is far more than a household ingredient. It supports food manufacturing, pharmaceuticals, beverages, baking, fermentation, confectionery, and countless industrial applications. One simple crystal quietly powers an enormous global economy. Visual description: candy factories, bakeries, medicine production, beverage filling lines. The trucks have arrived. The raw material has been inspected, but the real transformation has yet to begin. Inside these enormous buildings, towering machines will crush, clean, heat, filter, evaporate, and crystallize the juice hidden inside every stalk. What happens next is a breathtaking combination of engineering, chemistry, and precision manufacturing. In the next chapter, we'll step inside the heart of the sugar factory and witness how an ordinary plant becomes millions of sparkling crystals. Visual description. Massive factory doors slowly opening. Steam rises dramatically. Conveyor belts begin moving. Machines awaken. The moment sugarcane enters the processing line, every second matters. Massive conveyor systems move thousands of tons of freshly harvested cane toward powerful preparation machines. The goal is simple: maximize sugar extraction while preserving quality. From this point forward, nearly every stage is automated, monitored by sensors, and controlled with remarkable precision. Visual description. Sugarcane is unloaded onto giant steel conveyors. Overhead cameras capture the endless stream of cane feeding into the factory. Operators monitor digital control panels while warning lights flash across the production floor. Before extraction begins, sugarcane must be cleaned. Leaves, dirt, stones, and unwanted debris are removed to protect expensive machinery and ensure cleaner juice. Powerful washing systems and rotating cleaning drums prepare the crop for its next stage. Visual description. Water sprays remove soil, while rotating drums tumble sugarcane. Dirt flows away through drainage channels. Whole sugarcane stalks are too large for efficient extraction. Powerful rotating knives slice them into smaller pieces before heavy-duty shredders break the fibers apart. Increasing the surface area allows far more sugar to be recovered during crushing. Visual description. Massive rotating blades rapidly chop sugarcane. Shredded fibers move onto the next conveyor. Now comes one of the most important stages of the entire factory. Massive crushing mills squeeze the shredded cane with tremendous force. As the fibers pass between enormous steel rollers, sweet juice is extracted, while the remaining dry fiber, called bagasse, continues to another part of the factory. Visual description. Gigantic steel rollers compress shredded sugarcane as juice pours into collection tanks. The leftover fiber, known as bagasse, isn't discarded. Instead, it becomes a valuable renewable fuel. Many sugar factories burn bagasse in high-efficiency boilers to generate steam and electricity, allowing the plant to produce much of its own energy. Visual description. Bagasse conveyed into large biomass boilers, generating steam. Fresh sugar juice contains natural impurities that must be removed. Through carefully controlled heating and clarification, unwanted particles separate from the liquid, leaving cleaner juice ready for concentration. Visual description. Large clarification tanks with foam removal and automated monitoring. Although purified, the juice is still mostly water. Giant evaporators gently boil away excess moisture under controlled conditions, creating a thick, golden syrup rich in natural sugar. Visual description. Multiple effect evaporators releasing controlled steam. Inside enormous vacuum pans, concentrated syrup begins a remarkable transformation. As pressure and temperature are carefully controlled, microscopic sugar crystals form and slowly grow. Every crystal must develop evenly to achieve the desired quality. Visual description. Golden syrup swirling inside giant vacuum crystallizers. The crystal-rich mixture is transferred into powerful centrifuges, spinning at incredible speeds. Centrifugal force separates sparkling sugar crystals from the remaining syrup, producing the familiar white granules recognized around the world. Visual description. Large centrifuges spinning rapidly as sugar crystals collect inside. Fresh sugar crystals are now nearly complete, but they still contain moisture. Drying, cooling, grading, and packaging remain before the product is ready for homes and industries around the world. Beyond these walls, an enormous global journey is about to begin. In the next chapter, we'll follow these crystals from the factory floor to international markets across the globe. Visual description. Dry sugar moving along conveyors toward drying towers. Wide aerial shot of the factory fading into rows of shipping containers. Although the sugar crystals have formed, they still contain a small amount of moisture. Industrial drying systems use carefully controlled streams of warm air to remove excess moisture without damaging the crystals. This step ensures free-flowing sugar with a long shelf life and consistent quality. Visual description. White sugar crystals move through a large rotating drying drum while warm air circulates. Steam exits through ventilation ducts as sensors monitor temperature. Not every sugar crystal is exactly the same size. Precision vibrating screens separate fine, medium, and coarse sugar into different grades. This classification ensures that each product meets the exact specifications required by bakeries, beverage companies, food manufacturers, and consumers. Visual description. Sugar flows across vibrating sieves, while different crystal sizes are directed into separate stainless steel bins. Before any sugar leaves the factory, quality specialists perform detailed inspections. Samples are analyzed for moisture, color, crystal size, purity, and food safety. Modern laboratories combine automated instruments with trained technicians to ensure every batch meets strict production standards. Visual description. Scientists examine sugar under microscopes, use digital analyzers, and record results on computer systems. Once approved, sugar enters fully automated packaging lines. High-speed machines weigh, fill, seal, and label thousands of bags every hour, with exceptional accuracy. Automation reduces waste while maintaining hygiene and consistency. Visual description. Robotic filling machines package sugar into retail bags and industrial sacks. Conveyor belts move finished packages toward palletizing robots. Finished bags are automatically stacked onto pallets by robotic systems capable of lifting hundreds of packages every hour. Stretch wrapping protects each pallet from moisture, dust, and movement during transportation. Visual description. Robotic palletizers stack bags with remarkable speed, while automated wrapping machines secure the loads. Large climate-controlled warehouses protect sugar from moisture and contamination. Inventory systems track every pallet, allowing factories to manage thousands of tons efficiently before shipment. Visual description. Rows of towering sugar pallets, forklifts moving through wide aisles, digital inventory scanners. The journey continues beyond the factory gates. Trucks, freight trains, and cargo vehicles transport sugar across cities and countries, connecting producers with food manufacturers, wholesalers, and retailers. Visual description. Convoys of trucks depart the factory while freight trains carry container loads across vast landscapes. For many producers, the destination lies beyond national borders. Sugar is loaded into shipping containers and bulk cargo vessels, traveling thousands of miles across oceans before reaching international markets. Visual description. Container cranes load sugar onto cargo ships at a busy international seaport. Sugar is produced and consumed around the world. Major producing countries include Brazil, India, Thailand, China, the United States, Mexico, Australia, and several European nations through sugar beet production. International trade connects farmers, factories, shipping companies, food manufacturers, and consumers in one vast global supply chain. Every day, millions of tons move across continents to satisfy worldwide demand. Visual description. Animated world map highlighting major sugar-producing regions, followed by footage of farms, factories, ports, and supermarkets across different continents. From a single field to homes around the world, the journey of sugar is far greater than most people imagine. Behind every crystal stands an intricate network of agriculture, engineering, science, logistics, and global commerce. Yet another challenge awaits, one that will shape the future of sugar production for generations to come. How can factories produce more while protecting the environment and conserving precious resources? In the final chapter, we'll explore the innovations transforming the sugar industry and the future that lies ahead. Visual description. A montage of sugar crystals dissolving into coffee, bakeries, laboratories, cargo ships, and modern factories, ending with a futuristic refinery powered by renewable energy. Every year, sugar factories process millions of tons of sugarcane and sugar beet. This massive production requires land, water, energy, and transportation. While sugar supports economies and feeds billions of people, manufacturers are working to reduce emissions, conserve water, and improve energy efficiency. The future of sugar depends not only on productivity, but also on sustainability. Visual description. Aerial views of sugar plantations, factory cooling systems, water recycling facilities, and lush green landscapes surrounding modern refineries. What was once considered waste has become one of the industry's greatest strengths. Bagasse, the fibrous material left after crushing sugarcane, is used to fuel high-efficiency boilers, generating steam and electricity that can power large portions of a sugar mill. This approach reduces reliance on fossil fuels while making better use of every harvested crop. Visual description: bagasse feeding biomass boilers, steam turbine spinning, control room monitoring energy production. Today's sugar factories rely on intelligent automation. Thousands of sensors monitor temperature, pressure, flow rates, and equipment performance in real time. Operators oversee production from centralized control rooms, where advanced software helps maintain efficiency, consistency, and safety around the clock. Visual description: digital control room, operators monitoring large screens, automated machinery responding to live data. Robotic systems are becoming increasingly common in sugar factories. From automated palletizing to warehouse logistics and equipment inspections, robots improve efficiency, reduce repetitive labor, and help create safer working environments alongside skilled human operators. Visual description: robotic arms stack sugar bags while autonomous vehicles transport pallets through the warehouse. Innovation begins long before the factory. Farmers are increasingly using precision agriculture, satellite imagery, drones, and advanced irrigation systems to monitor crop health, optimize water use, and improve harvest planning. These technologies help increase productivity while reducing resource consumption. Visual description: drones flying over sugarcane fields, GPS-guided tractors, precision irrigation systems, healthy crops. Despite remarkable progress, the industry continues to face significant challenges: climate variability, changing rainfall patterns, rising production costs, labor shortages, and increasing demand for sustainable practices require constant innovation. Meeting these challenges will shape the next generation of sugar production. Visual description: changing weather over sugar fields, farmers adapting to new conditions, engineers discussing factory upgrades. Despite remarkable progress, the industry continues to face significant challenges: climate variability, changing rainfall patterns, rising production costs, labor shortages, and increasing demand for sustainable practices require constant innovation. Meeting these challenges will shape the next generation of sugar production. Visual description: changing weather over sugar fields, farmers adapting to new conditions, engineers discussing factory upgrades. Behind every bag of sugar are the people who make the process possible: farmers, machine operators, engineers, laboratory technicians, logistics teams, maintenance specialists, and countless others contribute their skills each day. Their dedication transforms a simple crop into a product relied upon around the world. Visual description: portraits of workers across the entire production chain, from farms to laboratories to shipping terminals. The journey of sugar spans months of careful cultivation, advanced engineering, rigorous quality control, and global transportation. Each crystal tells a story of science, precision, and collaboration on an extraordinary scale. Visual description: rapid cinematic montage retracing the entire journey, from planting and harvesting to factory processing, packaging, shipping, and finally, a family preparing breakfast. The next time you stir a spoonful of sugar into your coffee, bake a favorite dessert, or enjoy a sweet treat, remember the remarkable journey hidden inside every crystal. It began in sunlit fields, traveled through towering machines, passed countless quality checks, crossed oceans, and reached your table through the dedication of thousands of people and decades of technological innovation. Sugar is more than a simple ingredient. It is a story of agriculture, engineering, science, sustainability, and human determination working together to transform nature into something that connects people across the world. And perhaps that's the greatest lesson of all. Sometimes, the most extraordinary journeys are hidden inside the smallest things. Thank you for watching. Visual description: golden sunrise over endless sugarcane fields, transitions to the modern factory, then to cargo ships, supermarkets, families sharing meals, and finally, a single sparkling sugar crystal resting on a spoon. Fade to black. Every crystal of sugar carries a journey measured not just in miles, but in seasons of growth, moments of innovation, and the dedication of countless hands. The next time you taste something sweet, remember, you are experiencing one of the world's most remarkable manufacturing stories.